I'm Jack McDonald, the current president of the Amateur Astronomy Club. Here, we present a closer look at the 1 meter telescope, including faculty and current students.
Welcome to the 5th floor of the College of Arts and Sciences. My name is Ted Von Hippel. I'm a professor of physics and astronomy and the observatory director. Behind me, through this door right here, is our access to the 1 meter telescope on the roof of the College of Arts and Sciences. The telescope is now used for 3 different things. It's used for public outreach, teaching, and research. For public outreach, we run typically 3 events per semester where we let the public come and look through the telescope. For research, some of our faculty and students are using the telescope for their own research projects, some of which are externally funded. And for teaching, this telescope is used for our capstone observational astronomy course, where the students in that course learn how to use the telescope and each have their own project with the telescope. And they essentially own the telescope all semester. Every night of the semester is being used by these students to do their own projects on the telescope.
Nearly every clear night, students are observing in the 1 meter observatory, one of which is Joey Hamill.
Here we are at the 1 meter telescope. This big yellow thing is the mount for the telescope. It's an equatorial mount, and it connects to the entire truss structure that you see walking into class. And it runs all the way up through the building so that this telescope is isolated from the rest of the building, and any shaking in the building won't disturb the telescope, at least in theory. This telescope is of a design called Ritchie-Creation, and this mount is Cassegrain, which means it's through a hole in the primary mirror. This is the primary camera right here, and this is the filter wheel. All the wires that you see connect either the camera or the mount and the telescope itself to the computers that we've looked at in the control room. Also on this mount, we have these piggyback telescopes, and sometimes these get used for science, or sometimes they get used as finder scopes.
Currently, the 1 meter telescope has 2 instruments mounted on it. We just saw the imager, and now we're going to look at the spectrograph.
Okay, so one of the instruments we have on the back of our 1 meter telescope is a fiber-fed spectrograph. So these are optical fibers, the same kind that bring telecommunications across the Atlantic Ocean, but you can also use light for science. And the light from the telescope is collected down here. Some of it goes into an imaging camera, but there's a pickoff mirror that sends it into this device, which couples the light into this optical fiber here. And that carries it down into the classroom cabinet. And this blue camera here is what's imaging the star. And this other optical fiber carries a lamp of known light of thorium and argon atoms that allow us to establish the color scale and the wavelength scale in the spectrum. Okay, so here's the optical fiber that carries the starlight down to the control room and the cabinet, and we'll be there right now. Okay, so this fiber here, which I just pointed out upstairs, comes down and brings the starlight into the spectrograph. And inside the spectrograph, there's a collimator that essentially takes this beam of diverging light and makes it parallel. And that hits a grating, which breaks the light up into different colors depending on the angle. And then it goes through a prism that splits the light the other way, and that spreads the light into a ladder, a rainbow, but in a ladder form called an échelle for French. And that is imaged by this camera lens onto the charge coupled device, similar you have in your cell phone, except this one's cooled down so it has lower noise. And then this carries the signal of that image to the computer in the control room over there. Okay, as we talked about, the spectrograph splitting the light in 2 directions, one by the grating and one by the prism. That spreads the light into this échellogram. You can see these spectral lines, and these are like barcodes. Here we have light from hydrogen, light from sodium. All of these different barcodes represent different elements, and that allows us to determine not only the composition of the star, but how hot the star is, what the gravity or pressure on that star is, how fast it might be rotating, how fast it's moving through space. All these things are made possible. They say picture's worth 1,000 words, but a spectrum's worth 1,000 pictures.
Now that we've seen the scientific instruments on the back of the telescope, Joey will tell us how to actually operate the telescope in the telescope control room.
Welcome to the control room. Tonight I'm going to be the telescope operator, and I'm going to show you around the telescope operator station. So the first thing behind me, we have the TCS computer. This is the physical TCS, and it's got all the switches that run different aspects of the telescope. So mirror doors, tracking, motors for it, that's all here. Then we come over here. This monitor is the second TCS. That's not very important. The third TCS is this one. This is the software TCS. It's confusing, but fun. This software is the Sky 6, and the software that will keep track of the objects in the sky. We use this to point the telescope.
Whenever the telescope is in operation, there's always two people in the control room. One of them, the telescope operator, controls the telescope. The other one, the project scientist, either takes data through the camera or the spectrograph.
Hello, I'm the project scientist tonight, so that means I get to pick what we're looking at. And tonight I'm going to be looking at Cepheid variables for my project for EP425. So what I have to do is when I'm at this position on the computer, I have to start up the imaging camera. And to do that, I first have to connect the cameras to the system and then have them cool down to a certain temperature. So this is one of the calibration images that I'm doing today. When you take images for astronomy, you really don't get the pretty pictures you see every day with your iPhone or your Android camera. You have to take lots of different pictures and lots of different filters and calibrate them and use special software to be able to see the colors that we normally see every day. So right now that's what I'm doing. I'm taking calibration data so I can take this later and make my pictures very nice and pretty.
The project scientist often takes data over multiple months on the same object to eventually analyze it for the class project or a research project. Embry-Riddle's 1 meter telescope is the culmination of years of designing and millions of dollars. I hope you enjoyed this look at the 1 meter telescope on top of COAS. Be sure to check out ERAU's observatory website for more information on upcoming astronomy open houses.